Okay, so very good morning. Okay, so we'll start class. So, am I audible?
Yes, sir.
Okay, fine. Still, how many need to join here? Only four members. Right. Okay. So, start introduction chapter of unit one here. So, material is a substance which is formed based on the some ores, mines, as well as some uh, mud particles. Okay. So, if you look over the materials, so they are come into mainly three criteria. That means three types. One material is purely of elastic nature. So another material is of plastic. Okay. Another material is of a rigid. Okay. Another material is of a rigid. Okay. So now we can say these classifications are based on the behavior of the material. So when it is subjected to a different type of forces here. Okay. Now if you come into mechanical engineering field, if you come into mechanical engineering field, so most of the machine members or most of the machine structural members are subjected to tensile force, are subjected to tensile force, are subjected to compressive force, and are subjected to shear force, are subjected to shear force, and sometimes they are going to be subjected to combined forces also. They are subjected to combined forces, right? Now, as you need to predict the behavior of the material, whether it is going to sustain the given load or not. Suppose if you are going to apply the load over it, how much does it going to develop? Okay. Now, if an elastic material is subjected to an external loading, okay, if an elastic material, suppose if you take elastic material here, okay, so which is the best example for elastic material? Now, if the load is applied to this elastic material, what happens? Okay, if the load is applied to this elastic material, what happens here? So, hello, ah, ಇದೇ ಜಸ್ಟ್ ರೀಸೆಂಟ್ ಆಗಿ ಒಂದು ಲಿಂಕ್ ಕಳಿಸಿದೆ ನೋಡಪ್ಪ, ಅದು ಟ್ರೈ ಮಾಡು. Right. So, if you apply the load to the elastic material, it will go for certain deformation. Okay. It will go for certain deformation. Now, after removal of load, after removal of load, so this deformation disappears. Deformation disappears. Okay. This deformation is what disappears. Now, suppose if it is a nature of plastic material, if it is in nature of plastic material, if you apply the load, it is going to go for some deformation. So after removal of load, so deformation does not disappear. Deformation remains as it is. Okay. Next is what? A rigid body, okay, or rigid material. So now deformation is very negligible here. Deformation is very negligible. Okay. If you apply the load, deformation is a very negligible. Okay. Now, how you are going to say material is elastic, material is a plastic, and material is a rigid material? Okay. Now, it all depends on the property of a material. So that is what the elastic constant of the material. Okay. Elastic constant of the material. So now, based on that one, you can say within elastic limit, it is going to behave like an elastic material. After elastic limit, it is going to behave a plastic material. Okay. So regarding rigid materials, if we consider the properties, okay, the material which has a more brittleness, so for certain period of load or for certain amount of load, it is going to behave like an rigid material, right? So now how the deformation is takes place? So deformation is takes place as the molecules of the material are going to form some their original shape to be some deformed shape. So now it is going to cause the deformation for entire material or for entire component. Okay. Now, so as I say, if you consider the mechanical components, okay, so it is subjected to a different type of forces or loads. That is what tensile force, compressive force, shear force, and combined forces. So, for example, a connecting rod in an IC engine, okay, so it is subjected to tensile, compressive, okay, and if you consider a bolts in a bolted joint, if you consider bolt in a bolted joint, so now based on the load directions, it may be subjected to tensile force, it may be subjected to compressive force. Similarly, so it is imperative that we need to understand the behavior of the materials, okay, under the influence of the different types of loads or different type of force. Okay. 8 ಗಂಟೆ ಅಂದ್ರೆ 8 ಗಂಟೆಗೆ ಬರಬೇಕು ಕ್ಲಾಸಿಗೆ, 8:10 ತನಕ ಬಂದ್ರೆ ಹೆಂಗೆ? Now, one more important thing, as seen, so presently the all engineering field is of a multidisciplinary oriented. Okay, multidisciplinary oriented. That means an electrical engineer can do some work in mechanical engineering field, and mechanical engineering can do some work in civil field, and so vice and versa. Okay, this subject is going to give some more importance. This subject is going to give some more importance because an huge component and huge component to teeny component you need to analyze. You need to analyze. So let us take a huge component. It is a thick cylinder here. It is a thick cylinder. Now, if a thick cylinder is made of a material, so it is subjected to some internal pressure. Okay, internal pressure. So how it is going to make a behavior? Whether the for the provided internal pressure, whether it is going to be safe or not. Okay. Now, if you consider a teeny component, so let us take an
So screen is not seen.
not seen. It is there. Whether screen is visible or not.
Yes, sir.
Yes, sir.
Okay.
We can see, sir.
Now, if you consider a teeny component like a resistor, okay, resistor or an capacitor, okay, in a motherboard, okay, in a motherboard. Now, if it is a heated for a certain amount of temperature. So whether this resistor is going to sustain, whether this capacitor is going to sustain or not, you need to analyze. Okay. Now this is what, so you can understand or you can get. So what is the importance of this strength of material in multidisciplinary also. Okay. Now regarding analysis, so we can go for some sort of softwares also. Okay. Now this strength of material subject is, you can say, basic or fundamental requirement for a design and analysis engineers. Okay. Strength of material subject is a basic or fundamental requirement, okay, for design and analysis engineers. Okay. That means, suppose if you want to become a design engineer, or if you want to become a analysis engineer, or if you want to become a simulation engineer with using lot of softwares, now you must have a thorough knowledge about this strength of material. Okay. For example, if you take an simple rod here, okay, so let us go for an simple axle. Now simple axle, okay, so which is going to be used in motorcycles or or bikes. Okay. Now you must know what is the load, okay, load over the axle, okay, and what type of material, what type of material you required, okay, then what is the induced stress, okay. Suppose if you need to design for safe, okay, so you need to check it, you need to check it, and you need to check it. Okay. Suppose if you have the idea of strength of material, so you can easily predict, so this is going to be safe, this is not going to be safe, and so on. Okay. Now this is what all about introduction to the strength of material. Okay. So now we'll start the first bit of chapter. This is what stress. Now, can someone say what is the meaning of stress?
Restoring force per unit area.
Pardon?
Sir, restoring force per unit area.
Force per unit area. Okay. Any other meanings? Any other words or any other meaning? Hello? Hey, you should give some answer, whether it is right or wrong. You don't bother about it. You don't bother about the answer.
Resistance offered by the body against the deformation.
Good. Okay. Resistance offered by the body against the deformation, it is called as an stress. Okay. Now, regarding notations, some book they have gone for sigma, some book they have gone for small f, some book they have gone for small p. Right? This is what a notation. Okay? No. So for analysis purpose, let us consider a member here. Let us consider a member. Okay. Now I took an rectangle bar here. Rectangle bar. Now it is subjected to the load P. Load P. So and say it is subjected to load P. It is subjected to load. Now You just give the concept. If you apply the load to any member in its longitudinal direction, okay, so what happens to its dimensions? Whether those dimensions are going to be remains the same or dimensions are going to change.
Increases its length,
Increases its length, okay,
decreases
decreases
its width.
decreases its width. Good. Okay. Now let us take. I'll go for some irregular shape component here. It's subjected to the load P here. Okay. Now, as I said, so length is going to increase, other dimensions are going to decrease. Length is going to increase, other dimensions are going to decrease. Suppose for analysis purpose, if I pass a section plane here, okay, if I pass a section plane here, now it's going to become a two halves, okay, it's going to become a two halves, right? Now, what will happen as it's subjected to load and resistance force is developed inside the component here, okay, and resisting force is developed inside the component, okay. So now this resisting force try to oppose the external force which is applied over it, try to oppose the external force which is applied over it, okay. At the same time, at the same time, one more force is going to develop in transverse direction here. One more force is going to develop in transverse direction. So this force is called as a shear force. This force is called as a shearing force or shear force. Now, if you consider resisting force as a R, okay, and if you consider shearing force as a Q, okay, shearing force as a Q. Okay. Now, as the amount of shearing resistance so is less in comparison with the resisting force, in comparison with the resisting force, okay. Now therefore the intensity of the resisting force is going to oppose the external applied force, okay, externally applied force. So now you can simply say the stress is defined as the resistance offered by a body against the deformation per unit area, okay, against the deformation per unit area, okay. Now in practice, so this intensity of stress is called as a stress only, okay, intensity of stress is called as a stress only, okay. Now if you write the equation for stress here, okay, so now if you take a small element, if you take a small element, you can just go for analysis. Now I am going to simplify this diagram again only for two values, only for two values, okay. Now this is what Q, this is what R, this is what R, which is going to be equal to P, okay. So now you just look out here. Now mathematically what you are going to say, mathematically, so if you consider this as a normal stress, okay, this is equal to sigma equal to dr by dA if you gone for small elemental area, okay. So now where R is normal resisting force here, normal resisting force. So you can say sigma equal to R by A. So where A is cross sectional area of the member or material. Onkar, Onkar and Raghavendra Gowda. So be on time. Okay, be on time. Already it's 8:30. Now, now what happens as the component has to become in equilibrium state? Okay, as the component has to come into equilibrium state. So if P is the external force, if P is the external force, okay. So to get the element or to get the component in has to be in equilibrium state. So now this has to be equal to the inside resisting force, the resisting force which has been developed inside here, that is what R. So therefore P equal to R. Okay, therefore P equal to R. So now hence this stress equation can be written as P by A. Okay, P by A. So for that reason, if you are defining in a simple term or if you are defining in a simple meaning, you are saying it is a force by area. Okay, it works. But actually in technical term, this is what. So stress is defined as a resistance offered by a body against deformation for unit area. Okay, that is the actual meaning of stress. As the component has to be come into equilibrium state, so now this is what the external force which is applied over the component is equal to the resisting force developed inside the component. So now P equal to what? Hence we are replacing R by A to the P by A. Okay? R by A to the P by A. Right? Now, similarly, if you go on for writing the shear stress equation, so now the shear stress is noted with the letter Q. This is what Q by D, Q by A. Okay. So here Q is shearing force. Okay. Sharing force. So almost all it is going to be neglected when you consider the calculation of the normal stresses. Okay. Considered it has been neglected. If you consider the force which is going to act normal to the cross sectional area, now this sharing stress is neglected. Okay. Now let us go for what is the meaning of simple stress here. What is the meaning of simple stress? Okay. So now the simple stress is only one type of stress. Okay. Now these stresses are considered to be uniform over the cross section of the component. Okay. Simple stress means only one type of stress. Okay. And assumed assumed to be uniform over the cross section, over the cross section. Right. That means if we say simple stress, we are neglecting here a shear stress. We are neglecting a shear stress. That is what. If you look at this, particularly in this example, we are going to calculate the stress with respect to this resisting force only. Now we are neglecting this Q. Then we are saying it as a simple stress. Okay. Now distribution of this stress has to be uniform throughout its cross section area. Okay. Throughout its cross section area. But actually, if you look at the Saint-Venant's theory or Saint-Venant's principle, now the distribution of stress is not uniform throughout its cross section area. So it is going to be vary like a parabolic. It is going to vary like a parabolic. Okay. So that is what if you consider a bar subjected to force, now the variation of stress is in this way. Okay, variation of stress is in this way. I think this is called as Sandman's principal theory. Okay, Sandman's principal theory. Now, what we are assuming here, this is what a simple stress. Okay, this is what a simple stress. Now, this intensity of stress is uniform. Okay, this is what uniform throughout its cross section area. Right? This is what a simple stress. Okay. Now, let us go for analyzing the different type of stresses here. Let us go for analyzing the different type of stresses. Okay. Now, what are the different type of stresses? In just a say, what are the different type of stresses? ನೋಡ್ರಪ್ಪ ನನ್ನ ಕ್ಲಾಸಲ್ಲಿ ಮಾತಾಡಬೇಕು ಮಾತಾಡಲಿಲ್ಲ ಅಂದ್ರೆ ಕ್ಲಾಸ್ ಆಗಲ್ಲ ಇಲ್ಲಾಂದ್ರೆ ಯಾವ್ದಾರ ಕತೆ ಕೇಳ್ದಂಗೆ ಆಕತ್ ನೋಡಿ
Tensile stress, compression stress,
okay let's list one by one okay
shearing stress,
okay one is what
Tensile stress,
tensile stress,
god second one is
binding stress,
compressive,
compressive stress
compressive stress,
okay
shearing stress,
Shear stress.
third one is shear
shear
stress
stress.
right okay now we'll discuss one by one here okay? Now we'll discuss one by one okay? Now one more important term we have left. What is the unit of stress here? We have simply written here. What is the unit of stress?
newtons per
Newton per meter square.
Newton per meter square. So unit must be you must take here. We have left one bit here. Now P is what? It is applied load. Okay. P is applied load. Either this is in Newton or kilonewton. Okay. So A is what? It is the cross sectional area. Cross sectional area. Okay. So it may be in terms of mm square. It may be in terms of meter square. Right. So now unit of stress is what? Newton per mm square or Newton per meter square or kilonewton per meter square. Okay. Now let us look at the unit conversion here only. We will continue the types of stresses next. Now units of stress. Okay. Now one thing is Newton per mm square. Okay. Now whether this is equal to the mega Newton per mm square meter square. Mega Newton per meter square, whether this is equal to mega Newton per mm square, or you can say MPa. So MPa means megapascal. Okay. Whether this is equal to this one,
MPa.
no. Whether this is equal to right. Now I have written one simple unit here. This is what Newton per mm square is equal to megapascal. Whether it is right or wrong.
right.
Right. How? You give some hints also. Okay. Now Pascal unit is what? One
Newtons per meter square.
Newton per. ಕಾನ್ಫಿಡೆನ್ಸ್ಲಿ ಹೇಳ್ಬೇಕು ನಾನೇ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಅದು ಕರೆಕ್ಟ್ ಇರಲಿ ತಪ್ಪಿರಲಿ ಅದ್ರ ಬಗ್ಗೆ ವರಿ ಮಾಡಬೇಡ್ರಿ ನೀವು ಮಿಸ್ಟೇಕ್ ಮಾಡಿದ್ರೆ ಗೊತ್ತಾಗುತ್ತಾ
Newtons per meter square.
ನ್ಯೂಟನ್ ಪರ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ರೈಟ್ ಓಕೆ now look out here mega means how much 10 to the power of 6 right it is what Newton per meter square everyone agree with this one
Yes.
Okay. Now, 1 meter equal to how many mm's?
1000 mm.
1000 mm.
Understood.
Now you got 1 megapascal equal to 1 Newton per mm square, right?
Yes, sir.
Okay, you must
Yes, sir.
have the concept of unit conversion here. Kilonewton per mm square you need to convert, megapascal you need to convert, gigapascal also you need to convert. The thing is that unit should be of a same nature. Okay, unit should be of a same nature. For example, if you go on for putting the area in terms of meter square, and if you go on for putting the shear stress in Newton per mm square, so you are going to get the wrong answers. You are going to get the wrong answer. Okay. Now coming to the different type of stresses here. Coming to the different types of stresses. So let us go for one by one here. Now, whether are you getting the speed of teaching is okay or it has to be reduced? ಹೇಳ್ತಾರೋ ಸ್ಪೀಡ್ ಓಕೆನಾ ಏನಿನ್ನ ಕಡಿಮೆ ಮಾಡ್ಬೇಕಾ ಇನ್ನ ಹೆಚ್ಚು ಮಾಡ್ಬೇಕಾ?
Okay, sir.
It's okay, sir.
Okay. Now for understanding this tensile stress, okay, let us consider a rectangular bar, okay, which is subjected to load P, okay, which has a cross sectional area, which has a cross sectional area A here. Okay. Now as you are applying the load over here, as I said earlier, so what happens to the length here? What happens to the length?
Increase.
Increases. Okay, it is going to increase. Okay. So now tensile stress is defined as a component when it is subjected to load. So it is going to increase its dimensions in the direction of load or in the direction of applied load. Okay. So now tensile stress is noted with the letter sigma t normally. Tensile stress is noted with the letter sigma t. So this is equal to what? P by A. Okay. P by A. Now where P is, so P is applied load. P is applied load either in Newton or in a kilonewton. So A is cross sectional area. A is cross sectional area either it is meter square or mm square. Right? So in tensile stress what happens? So the length of the component is going to increase. Right? Length of the component is going to increase. Okay. You can say it is subjected to the tensile stress. Okay. Next one is what a compressive stress. So now this is of a positive value. Okay, tensile stress is always positive value. Okay. Now let us consider a rectangular bar which is subjected to the compressive load. Okay, which is subjected to the compressive load. So now in this case, what happens for the dimensions here? In this case, what happens to the dimensions?
Decreases, sir.
Increases.
What it decreases?
Length.
Length decreases. And what about the other dimensions? What about the other dimensions?
This increases, sir.
Increases. Okay. So now
Diameter increases, sir.
diameter ಇಲ್ಲಿ rectangle bar ಐತೆ.
Width,
Yes.
width.
Circle ಕಂಡಂಗ್ ಕಾಣುತ್ತಾ? Okay.
Okay, sir.
Let it be.
Confused.
Okay, let it be. Okay. Now compressive stress is defined as the stress which is going to causing the shortening of the bar. Okay. Shortening of the bar in the direction of load. In the direction of load, then you can say that type of stress is what a compressive stress. So compressive stress value is minus here. It is of a nature is minus. Okay. So here also what? Now in this case what happens? So it's caused the extension of the bar here. Tensile stress is what? It try to extend. It tries to extend the length of the bar. Okay, that means it's causing some extension. Okay, but here in case of compressive stress, it is going to shorten. It is going to shorten. So where P is what applied load here? P is applied load either in Newton or either in kilonewton. So A is cross sectional area. Okay, what meter square or mm square. Now tensile stress what happens? It is going to extensioning, it is going to shortening. Okay, there is a difference. Length decreases here in compressive stress, length increases in tensile stress. Okay, now let us go for shear stress. Let us go for shear stress. Okay, now shear stress is defined as when a load is going to act parallel to cross sectional area of the component here. Parallel to cross sectional area of the component. Okay. So let us take an example here. A rectangular bar is there. Now a load is applied here. Now load is applied here. So now what happens to this object? Whether it's going to remain the same or whether it is going to give some different shape or it is going to change entire its shape.
Shape changes, sir.
Shape changes. Okay. Now whether this is a deformed shape. No, this has to be straight line, not an inclined line. Okay. Now it is going to create some obliquity about the reference plane or about the fixed position. Okay. Now this type of stress is called as a shear stress. This type of stress is called as a shear stress. Okay. Or one more thing, you can say if you consider a bar and if you apply the load here, okay. If you apply the load Q, okay. Again, if we made this one into an slits here, okay. Now what happens? So internal resistance is generated in the opposite direction of the applied load. Okay. That is what? So Q equal to R here. Now shear stress is defined as what? Now this is what, let us look out here only. This is what cross section area of the component. Cross section area of component or a member. Okay. Now shear stress is noted with letter tau here. Shear stress is noted with a letter tau. Okay. Or sometimes it is noted with a letter Fs or small ps. Okay. Small ps. Okay. Now this shear stress tau is defined as so Q by A. Okay, Q by A. So now if you look at this particular example, this is what P by A. Okay, so now where P is applied load, P is applied load either in Newton or kilonewton. Okay, so area is cross section area of the component. This is in terms of meter square or mm square. Okay, right. Okay, now just go for a revision here for 5 minutes. For 5 minutes. So, what are the contents covered today here? So, contents covered is so introduction about the subject. Okay. So then introduction about the so definition of the stress and different types of
Types of
stresses. Okay.
stress.
Okay. Now, you have any doubts over these three topics?
Sir, shear stress answer.
Now, regarding shear stress, you have a detailed topic in this chapter only, so we can discuss another time also. Okay. Now, one example I can quote for the shear stress is okay. Uh, if you look at the cutting of a paper, if you look at the cutting of a paper, otherwise, example sharing. Okay, just one thing is now let us look out here. Now you have an bar here. Okay, you have a bar. Okay, suppose with the help of some sharp chisel, okay, you want to cut it. Okay, you want to cut it. Now the force which is going to act on this particular cross section area is going to cause the shear stress. Okay, is going to cause the shear stress. Okay, shear means what? So just like making some obliquity or just like changing its shape, changing its shape, right? So I think you come to know this is shear stress in next topic. I hope you have a topic only simple shear stress. One topic is there, we'll discuss it. Okay, it is going to create obliquity. Okay, now if you consider only one plane object here, okay, now I took only two-dimension object here. Okay, now if I apply the load over here, okay, now I will fix this bottom portion. I will fix this bottom portion. Okay, now what happens here? It is going to give this new shape. It is going to give this new shape, right? Now if you look over the small portion of individual elements here, okay, small portions of individual elements here, okay, right. Now I gone for small elements here, individual portions of the component. Now just look out, this is going to be slide over this surface. Okay, this is going to be slide over this surface. That means so now these are elements are subjected to sharing with one another, with one another, right? Clear? Now we can say shear stress tau equal to P by A here. Okay, P by A. Now what happens to the in case of tensile stress or compressive stress? Let us look out here. Now I'll go for tensile stress for this fixed position. Now it's going to get this shape here. What happens? It's going to elongate its elements. Okay, it's going to elongate its element, right? Similarly, if you consider the compressive force here, compressive force here. Now what happens, this tries to decrease, or it tries to shorten the length of the each elements. Okay, clear. Now the thing is that in shearing it is going to subject it to the stresses. Okay, in compressive stress is sorry, in tensile stress is subjected in this way, or stress is going to act in this way, but in case of compressive stress is going to be act in this way, right? Parallel to surface, okay, a shear stress, perpendicular to surface, based on the low direction, it may be tensile or it may be compressive, right? So I'll end up here. We'll continue afternoon. I think today you have afternoon class at what time?